All right, so before we go to the molecule formula, let's just go through the gram formula, mass, and moles of compounds. Now, I've got an example that says calculate the number of moles in 1.52 grams of H2SO4. So you still use the same thing, same analogy. You want the number of moles. We know what the number of moles is mass all over the molar mass. It's the mass all over the molar mass, right? We know. But now you should add it up. You should add up your molar mass because now it's a compound. Okay? So here you add it up. We have two hydrogen atoms there, so you're going to say 2 times 1.008 gives you this answer. You see, sulfur is there's only one there, and then oxygen is 4 of them, and then you say 4 times 15.999, it gives you this answer. When you add them up, they will give you 98.078, and then you say number of moles is equals to 1.52 all over the added up molar mass, and it will give you this answer of 0.01549786904 moles. Okay, and then find the number of grams in 0.05 moles of H2O. Again, you still use the same analogy. How do you find the grams? You say the number of moles, you multiply that by the molar mass, but with the molar mass you add it up because it's a compound. Okay, so the number of moles is 0.05, and then when you add that the molar mass of H2O, you will get this, and when you multiply them out, this is the final answer that you get. Okay, and then the last one on this one is how many molecules are there in 0.25 moles of SO. So we now know that 1 mole of SO is equal to 6.02 times 23 molecules or more or atoms. Okay, yes, 1 mole is equal to 6.02 times 23 molecules or atoms. It's still, yeah, still the same analogy. You get in 1 mole of a compound, you get the same number, which is 6.0223 molecules, and of an element, which is going to be atoms. So again, you still use cross multiplication, same analogy. You're gonna multiply this by that, and then in 0.25 moles of SO, we get this much of molecules. All right, and then the molecular formula. Please note the difference between the two, between the molecular formula and empirical formula. The molecular formula is a compound as a formula that shows the actual number of atoms in each element that are in one molecule of the compound. It shows the actual number. Okay, so basically, empirical formula is in the simplest form, right? You can see there is an example. You can see that if with empirical formula, you get the simplest form of it. All right. An example there is determine the empirical and molecular formula of a compound whose composition is 52.1435238% of carbon and that of hydrogen and that of oxygen by mass. So it says by mass, so we can convert all those percentages to grams. Okay? And this right here is not that very clear. So what I will do is that I will send a picture on the WhatsApp group, and if you get lost along the way, you will contact me because I can see it's actually not that clear. So even if I try to, because I cannot even write it down here, I'm using a finger, so the writing is not that perfect. And then percentage by composition by mass, that is the last one. Before we go into this one, you need to know the empirical formula and molecular formula, and you need to know the atomic mass of each element in the compound, right? So here's an example. Find composition by mass of each element. There we had C2H6O. There's it. I don't know if I should go into this one because I didn't explain on top the molecular formula, so I don't know. But here, but let me just, yeah. So that is the one you want there. So we say you work them out, each element out, because it says of each element, composition by mass of each element. Okay, so you want to know how much of a percentage does each element contain in that particular compound. So for carbon, we have two of them, so you're going to say 2 times 12.00, it gives you 24.022. And then for hydrogen, we had 6 of them, so you're going to say 6 times 1.008, it's going to give you 6.048. And then for oxygen, just 1, so it's going to give you 15.999. And then when you add them up, you should add them up, they'll give you 46.069. Then you go find the percentage. So basically for each one, you say what you got there divided by this total times 100, and then it will give you the percentage. Okay, how should you know you're correct? When you add this percentage up, it should give you 100%. Okay, so percentage by mass of carbon, it's 24.022 all over 46.09 times 100 gives you 52.14352.384%. And for hydrogen, still the same thing. You write it what you got here divided by 46.069, you times it by 100, it gives you that. And then same for oxygen, you write it here divided by that times 100, it gives you that. When you add these up, they will give you 100%. Okay, that's just to check if you on the right path. Okay guys, so please do feel free to contact me to ask questions. If you lost, feel free to do so. Okay, and for this one, I'll just send a picture on the group because it's not so clear, so it's gonna be hard explaining it. Not hard, but I don't think you'll actually see what I'm talking about. Thank you.